This unit is built exclusively for Herc rentals in the North American market. This is the MS7500/6500. It's capable of 7,500 SCFM of dry air circulated to and from a drying environment. The unit can be fired with natural gas, propane, or all electric. It will run on 460 to 480 volt, 3-phase. Voltage should always be checked before operation. Many startup problems can be avoided by doing a preliminary check of all of the components of the unit, the wiring, just a quick look to make sure there's no debris in the unit and the filters are clean and ready for operation. The MS7500 can be operated either with a full electrical generator or with natural gas, propane, and an electrical generator or an electrical service. If the reactivation is set to high and the reactivation switch is set to electric, the unit will need 180 full load amps of 460 to 480 volt 3-phase power. If the selector switch is then selected to low, it drops the electrical requirement to 147 full load amps of 460 to 480 3-phase power. If you select the gas input, the electric load actually drops to about 21 full load amps of 460 to 480 volt 3-phase power. And then we need to connect gas, either propane or natural gas. We're going to use approximately 500,000 BTUs per hour full load to operate the dehumidifier. That equates to about 5 gallons per hour of propane or 500 cubic feet of natural gas per hour. The unit has a startup procedure on the side of the unit. You can review this for proper sequencing and startup of the unit, the variable airflow adjustment, humidistat, dew point, and the shutdown procedure. Also located on the side next to the startup procedure is our quick troubleshooting guide to try and help you through any common issues that might happen with the unit over time. Both of these are available in 3 languages, suitable for anywhere in North America. This is the unit nameplate. This shows the serial number and the model number specific for each unit that we build. Those 2 numbers are essential to provide access to service and parts as the unit ages. Please make a note of this when you call our service department for assistance. The first step to starting the unit is to remove the shipping covers and check the inlets for debris. On this end of the unit, we have the reactivation entering air, and we also have the process air entering air in 2 openings. All 3 of these openings should be removed and checked for debris. Once the shipping covers have been removed and stowed, we can inspect the reactivation inlet filter for cleanliness. Should be replaced whenever it's dirty. Around this side of the unit, we'll inspect the process air filters next. Around the corner is the process inlet filter access door, accessed with a screwdriver and the quarter turn openers. You can open the door and inspect the process air filters. In the process inlet filter compartment, we have an adapter plate for the reactivation air outlet. If the reactivation air needs to be ducted out of an environment, we can use that adapter plate on the reactivation outlet to connect to a 20-inch flexible hose. Next, we want to move to the wheel removal access compartment. We then open this and review the chain drive and the sprocket, the drive mechanism, and the rotation detector switch. We should also take a look in this area to make sure there's no debris in this area as well. These are the process outlet openings. Both of these shipping covers need to be removed and stowed, and we'll inspect the blower and the outlet for debris. Around the corner from the reactivation air inlet is the reactivation air outlet. This is the shipping cover plate, and this can be lowered to provide exit for reactivation air or the waste airstream. To lower the reactivation outlet shipping cover, you remove the 2 pins and lower the cover. At this time, you can also open the reactivation burner access door and inspect the burner for debris and cleanliness. Next, we want to move to the high voltage panel. This panel is located above the process air outlet, and you open the latches and the panel will flip up. Once the panel door is open, you can slide the finger guards over, and with the voltage off, you can check the wiring for tightness, inspect the circuit breakers to see if any of the circuit breakers have popped off in shipping. You can reset the breakers, reset the panel, and you'll be ready for operation. Next to the high voltage controls, we have the gas burner controls. This is the gas train, a pressure gauge showing your inlet gas pressure, which should always be between 7 and 14 inches of water column. And then we have the burner manifold gas pressure gauge, which shows the proper manifold pressure for the gas entering the burner. This can be adjusted by adjusting the Maxitrol Selectra valve if required, or the main inlet gas pressure regulator if required. The control and flame safeguard is located on the back panel. On the panel, the gas pressure requirements for either natural gas or propane are listed on the data sheet located on the back of the access panel. Right next to this drawing is a complete wiring diagram of the unit for troubleshooting. On the end of the unit is the control panel. This is a low voltage panel that does not require PPE equipment to service. We can check the unit for wiring problems or for operational problems by reviewing the annunciator panel. On the right-hand side of the control enclosure, we have the VFD controller. This is a variable frequency drive for the process blower. We can adjust the speed of the motor by increasing or decreasing this knob. The emergency bypass is available, but the power should be removed from the unit before you switch to the emergency bypass. This should not be done while the unit is operational. On the annunciator panel, we have green indicating lights for good things and red indicating lights for bad things. Power on, VFD, temperature, call for dehumidification, which is controlled by the humidistat jumper or a remote humidistat, and then we prove the reactivation airflow as well. The red lights are for faults. We have the reactivation flame failure, which would require a reset of the burner. This is normal when you're starting a unit on a new gas supply as you purge the gas line. The gas has to reach the burner for it to light, of course, so this might need a reset a couple of times on a brand new installation on gas. Then we monitor the reactivation temperature to verify it's within range. The DH rotor, dehumidifier rotor, must rotate at around 15 revolutions per hour. The reactivation high limit temperature switch will cause a fault if we overheat the reactivation. This can be caused by a dirty filter or ducting that might have collapsed on the reactivation. And then we have another fault, which is a general fault, which then can be interpreted down in the Corel controller. This unit comes equipped with a humidistat jumper plug. This completes the circuit to allow the dehumidifier to run continuously. This is a twist lock fitting and should be checked for operation. When it's removed, we do offer a remote humidistat, which can be placed in a drying environment, and this can then be inserted and the dehumidifier will cycle on and off as required by the humidity setting. On the right side of the panel is the emergency stop. This will kill all power to the panel and to the unit at this location. Verify the emergency switch is pulled out for operation. On the left-hand side of the control panel, we have the operating switches. We have a supply fan, which can be selected to auto or continuous. In the continuous mode, the supply fan will run continuously, and the dehumidifier will cycle on the remote humidistat if one is available. In the auto mode, the unit will cycle completely on a remote humidistat. If the humidistat jumper is in place, the unit will run continuously. Below the power on light is the reactivation selector switch. For reactivation power, we either run the unit on 100% electrical from a generator or a power source, or we can run it on natural gas, and it requires a much lower power source requirement. On the reactivation electric side, we have an option to go for full electric reactivation, or we can reduce the requirement to approximately 100 kW of electric heaters as the generator would require. Normal would be for that switch to be in the high position for full dehumidifier capacity. Now it's time to connect the return ductwork to the dehumidifier. This is 20-inch flexible ductwork with 3-inch pitch between the ribs. This unit has a high suction pressure, and it's capable of sucking the duct closed if the duct is not secured properly to the drying environment and to the unit. The ductwork is connected with quick connect clamps to the unit. Care should be taken to avoid any sharp bends or kinks. The return ductwork should also be anchored so the suction pressure of the unit doesn't draw the ductwork closed or collapsed. Now we can connect the 20-inch supply ducting. For the supply, we use 6-inch pitch as measured between the ribs. This is pressurized ducting. Care should be taken to avoid any kinks or sharp bends in this ducting as well. All 4 of the connections should be connected for proper flow from the dehumidifier. On the side of the control panel, we have the main disconnect switch, which is shown in the off position. We also have cam lock connectors to connect the 480 volt 3-phase power and the ground connector. Now it's time to connect the power cables to the dehumidifier, starting with the ground, and then the 3 connections for the 3-phase power. This should be done with the generator off, and the connection should be verified tight to the unit. With the power leads now connected to the unit, we can turn the power switch to on. This will start warming up the microprocessor and the controls. Initially, you'll get a phase incorrect. We should wait for about 30 seconds to make sure the control is all warmed up. And if not, we have to correct the phase of the unit by reversing 2 of the power leads. This should be done with the power off. Now with reversing 2 of our power leads, we're able to turn the power back on. The phase incorrect light will still light for a period of time as the controls actually warm up. So initially you can wait for a period, and then we can go for a startup of the unit. After a short period of time, you'll see that the phase incorrect light has now gone off. The control has sensed the proper phase and voltage being supplied to the unit. We are now into a pre-startup mode, and we move to the selector switches. We will select the unit to be reactivated with electricity. We're going to select the low reactivation setting based on my generator capacity, and then we select the switch to auto. This will initiate the microprocessor to start its self-check process of operation with the unit. We'll wait for a period of time up to about a minute before the microprocessor will sense things are correct and allow the unit to start. Initially start the unit, you'll see the screen actually loading. This is the controller performing a self-test and actually warming up for operation. This takes approximately 1 to 2 minutes. At this point, we're now starting the self-check process, and it's starting the CFM blower, the supply blower. That's the supply motor spooling up. The VFD is doing a soft start on the process air blower. Reactivation fan is on. After the unit's up and operational, you can see that the CFM is close to 7500 CFM. This can be adjusted with the variable frequency drive. We're actually warming up the reactivation heat now. The heat rate is on the last heater contactor. This is a variable heat rate. Just fine-tune the heating of the reactivation. You can page down, and this is a screen for a optional dew point transmitter. This shows us the rotor pressure drop, which should be somewhere around 1 to 1.2 inches of water column. The enclosure temperature is also monitored. We have our calculated reactivation inlet temperature set point of 285. We can see that we're still warming it up as we're starting the unit. We're showing stage 1 on, 2, 3 are on, stage 4 are on, stage 5 is off. We're now asking for 100% of the heat energy. This shows our unit status. And we're back to runtime hours. The time, date. This is our software revision to make sure this is current. And we're back to our original screen. After the unit is run and you're complete with the project, you always want to turn the unit off with the selector switch first. This will stop the supply blower and it will allow the reactivation blower to run for approximately 2 minutes to cool down the electric heaters. Now the reactivation air blower is timed out. We see that the green light has gone out on the panel. So the flow is off of the electric heaters and they have cooled down. So now it's safe to turn the power switch to off. Disconnect the power leads from the generator off, disconnect power from the unit.